Hey everyone, my name is Jessica. Today I'll be talking about how GABA blocks pathological but not acute TRPV1 pain signals. So let's get into it. So what is pain? Pain is a sensation that signals cell damage. Pain can be processed by the body as either motivational or discriminative. Motivational pain is the bad sensation that you feel which makes you not want to enjoy that experience again, which prevents repetitive cell damage. Discriminative pain is just a mechanism that your body uses to ensure to locate specifically where the pain is coming from. This occurs as a result of nociceptive signaling in the peripheries. Nociception. Nociception by definition is the encoding of harmful stimuli in the peripheral nervous system. Today though we'll be focusing just on the thermonociception as is related to the TRPV1 ion channel. Thermal nociception is pain induced by heat or cold temperatures. As you can see in this diagram below, it is involved in two pathways, which I'll further clarify in the next slide. These are the dorsal column lemniscal system and the anterior lateral system. So pains of nociception. Afferent nociceptive fibers are those that send information to the brain. These travel back to the spinal cord and synapse in the dorsal horn. The signal moves up the spinal cord from the lamina that it terminates at and moves to the thalamus by either the dorsal column lemniscal system or the anterior lateral system. It is then processed in the ventral posterior nucleus and is then sent to the cerebral cortex via the posterior limb of the internal capsule. The brain then releases a specific hormone or chemical to inhibit or reduce this pain sensation. What is TRVP1 ion channels? These regulate the human body temperature. These channels are predominantly found in the nociceptive neurons in the peripheral nervous system. It is also involved in the detection of burning pain. They are highly permeable to calcium, which I'll further elaborate on how they exchange calcium ions and why. They also modulate pain in many inflammatory pathways. So I've included a visual representation of the TRPV1 ion channel, and as you can see it's mainly composed of alpha helices. It is actually symmetrical. It kind of looks like hemoglobin in a way where it's got 4 subunits, all of them being symmetrical, but in the case of hemoglobin we've got alpha and beta subunits, but in this case they're all symmetrical. They have 4 binding sites and it's got a calcium ion channel. I've included a YouTube video that demonstrates the 3-dimensional structure of TRPV1 ion channel, so in your spare time if you want to have a look at the structure you most definitely can. GABA receptors. GABA is an inhibitory neurotransmitter found in the central nervous system. It's also found in the peripheries. It's synthesized in the brain from glutamate. It is involved in nociception in the peripheral nervous system. As you can see in the diagram below, this is a visual demonstration of a GABA receptor. As you can see, it's got 5 subunits, 2 of them being alpha, 2 of them being beta, 1 of them being gamma. Calcium enters through this channel. In the research article that I reviewed, the aim of the experiment was to examine GABA receptors and TRPV1 interactions, so how they interact with one another and also their relation to the entire nociceptive pathways. How does interaction promote pain reduction? So what pathways does it affect and how does it achieve this by? What is the pharmacological importance? So does this lead to any drug development? Methodology. Genetic biomechanic approach was taken for this experiment. They produced a tagged TRPV1 channel, which is synthetically created by the affinity tagged version of TRVP1 from mice. Tagged one was found to have a higher molecular weight compared to the native one, and tagged did not impair trafficking of TRVP1. GABA and TRVP1 interaction. There are no secondary messengers involved in this interaction. The channels are in close proximity to one another. TRVP1 receptors activate GABA release in the nerve endings. GABA activates GABA receptor to reduce TRVP1 sensitivity to calcium. Hence, calcium concentration is modulated. So I'm just going to explain what's going on in this diagram. This is just a systematic diagram of what actually occurs and how pain is reduced. So GABA and TRPV1 channels is a distinct reaction and has a direct effect on nociception. Once injury or inflammation occurs, inflammatory molecules attach to inflammatory receptor sites. This stimulates the TRPV1 receptor channels to open and allow calcium ions from the extracellular environment to move into the intracellular environment. These calcium ions are then released by exocytosis. GABA, with its two subunits, come and attach to the GABA receptor site. More calcium obviously flows through the channel, hence the intracellular concentration of the cell is more concentrated than that of the exterior environment. Furthermore, this induces an adverse effect and decreases the pain sensation. Reducing pain. My study shows that pain modulation has interaction with various other channels, so it's not just specifically TRPV1, it also has a cascade reaction for other receptors near it. TRPV1 acts as a linking pathway for different pain receptors. Inhibition of TRPV1 results in reduced pain stimuli, which we've seen previously in the diagram that I've showed you. Baclofen is used to activate GABA artificially. So building up on what I said before, as you can see in this diagram, you can see that baclofen has decreased everything in the table here. This demonstrates to us that not only is GABA stimulation has an effect on TRPV1, it also has an adverse effect on other channels, such as you can see here. Here the control remained constant. NGF receptor sites had a dramatic change. 5-HT also had a dramatic change with the presence of GABA. BK also same thing. PGE2 receptor sites didn't actually have a change. And lastly, PMA did definitely have a dramatic change. So as you can see, baclofen does have a dramatic effect on these receptor sites. Pharmacological importance. Conclusively, this report explores the effect of TRPV1 receptor channels on nociception. When pathological pain occurs, it promotes the GABA release and causes a series of cascade reactions whereby the non-permeable GABA B1 agonists can become a valuable pathway for the production of anti-pain therapy. This report opens the idea of future development of TRPV1 centric pain therapeutics. I hope everyone has learnt something today. Thank you for listening to my speech.